So very warm welcome to all in online lecture series. So I am Professor Sandeep Aher as a lecturer Sandeep Polytechnic Mechanical Department Sandeep Foundation Nasik. So friends, today we are going to discuss that new technological non-traditional machining process, that is laser beam machining process. So all are the aware about that laser. So what is meant by exactly laser beam machining processes? Laser, it is a light amplification stimulating emission and radiations. So that energy, high electrical energy formed in form of beam in a single monochromatic light, and machining is to remove the material. So that's why these material processes says the laser beam machining. It shortly says LBM. So every process has certain course outcome. So in this chapter, that course outcome is to maintain the non-traditional machining processes to make complex and hard machining components by under these non-traditional machining processes. So principle, this is the electrothermal based non-traditional machining process. In that process under the classification of electrothermal based energy, which works on the basis of laser. Laser means light amplification stimulating emission and radiation, and that is used to cut the material. That is the basic principle. In laser beam machining, that shortly says LBM, electrical energy is used to generate high energy coherent photons. So electrical energy is used to generate high energy coherent photons. Now compared to the EBM, electron beam machining, their high kinetic energy of electrons is converted into heat energy. But here that electrical energy is used to generate high energy of coherent photons, then it is possible to cut the material from the workpiece. So instead, see the next setup of laser beam machining. So every process, that figure is compulsory. Without figure, no one can understand the how it works, that particular process. So just observe this figure. What are the components? That means construction related. Then we'll see the one by one its function, then its working, then add the what are the process parameter, then its advantages and disadvantages. Now in this figure, we observe your workpiece, and we always say that workpiece always connected to the positive terminal, that is anode, and cutting tool always connected to the negative terminal, that is cathode. So that flash lamp indicates as a cutting tool. Okay. So cutting tool always should be rubber rod or crystalline materials are like. So here that is a workpiece. Now above the workpiece that lanes are provided. Why that lanes are provided? So n number of rays are coming here, and that rays gets coherent in a single point. So that is the function of lanes. Then these rays shows are the parallel way, that is a laser light beam. Then as the ruby crystal rod is one of the rod, that rod get energized this high frequency of light, so that rays, that is the ruby crystal rod, and this ruby crystal rod at the both end, upward and bottommost portion, that is reflective mirrors are there. So two types of mirror. In at the topmost 100%, reflective mirror, and then at the bottom partially reflective mirror, because in top at 100% reflective mirror, because they have not scattered in upward direction, so that's why 100% reflective mirrors are there, and it get more concentration, so that purpose 100% reflective mirrors are there. Then here, that yellow color strips indicate the flash lamps, and there is a one of the xenon tube materials, so that materials to emit the pulses in a second, thousands of pulses are generated, means flash are generated. So these are the simple basic component. Now we are going to see that is exactly working. Now every process that power supply is necessary, so that power supply, DC power supply under the capacitor, because it is storing the charge, then it required in high amount, then it supply it, so that purpose that capacitor is required. So with capacitor that high DC power supply is on, then this flash lamp gets start the flashes towards the ruby crystal rod. So thousands of flashes are generated continuously, and these flashes, like this black red arrow, nothing but a flashes, get absorbed to the ruby crystal rod, and that ruby crystal rod gets energized with high frequency, and that frequency may be very high, so that frequency to generate these laser rays, so that rays gets toward the lens or bottommost portion, because they have not scattered in upward direction, because at the topmost reflective mirror position is there. So these rays, observe here, a number of parallel rays are towards the workpiece, that means photons, and this again coherent on the lens, and that after lens they are passing in a single monochromatic light, and this light get concentrate on the workpiece, and thus to remove the material in form of melting or vaporization. So this is the simple working. So let us see one by one at what exactly construction, working, and process parameter, advantage and disadvantages. So now friends, that laser beam machining processes consist of similarly components related to the further processes. Power supply is the common. It is used to provide energy of excitation of electron from lower energy level to higher energy level. That point is very important, because that energy supply is required to move that electrons from lower energy level to higher energy level. This gives power to flash lamps which produce light energy, and the laser material is exposed in light energy to keep storing energy. Then laser discharge tube. The laser discharge tube is filled with the laser material. It is made up of xenon tube, and whatever that laser materials, there are many different types of laser material available, but in later machining mostly CO2 is carbon dioxide, it is a pulse or continuous wave, and neodymium doped yttrium aluminum garnet, that shortly says ND as YAG, is used. Now, focusing lens. A focusing lens is used to laser machining operation to focus laser at workpiece. That purpose focusing lens are used. Now, capacitor. Oh, already known about that. The capacitor, because most of processes, this is a common parts to operate the laser beam machining at a pulse mode. Capacitor is used, means now storing this charge. Now, reflecting mirrors. Two types of mirrors are used. At the top 100% reflective, and at the bottom partially reflective, because at the top they never scattered or move in upward direction. So that's why restrict that flow, and partially reflective and the bottom because they have passed towards the workpiece. Now we'll see the working. As already known, that indicate the full form light amplification by stimulated emission and radiation. So when DC supply is on, so when electrons of atoms absorb energy from an external source, the electrons which are in its original energy level, then after supply they jump to higher energy level. This is not a stable condition of atom. So this electron emits the absorbed energy in form of photons and come back to its original state. So that is the function of flashlight. An atom will emit double energy to return at its original state when an atom which is already at higher energy level absorb energy, and the energy emitted by the atom has same frequency and wavelength as the stimulated energy. And this is the fundamental of laser. If the laser material is placed in presence of some other energy source, so it absorbs energy at some extent and release it when reaches its absorbing limit. So friends, this is high amplitude light beam called as laser. So laser shortly says high amplitude light, and LBM works on the basic property of laser, so which is a narrow monochromatic high intense light which can cut or in form of vaporization melting of the metal, also non-metal, and that system also prefer in medical surgeries also, that laser like operation. So student, that working is very simple. You can write first full form of the light amplification by stimulating emission of radiation, then second says the which principle works on the base of these processes, third mention the non-traditional machining processes, there is no contact between cutting tool and workpiece, then it's some advantages disadvantages like this we are going to see, that is a process parameters. So I am showing here only normal range are given, because in every process that theoretical sentence are given, so that's why I'm doubtfully here in tabulated form. So laser materials, that is a rubber rod or CO2 materials are used. That rubber rod get energized when that flashes get absorbed. So that type is solid, and CO2 already known that this is a gaseous form. That's wavelength 0.69 micron. Here CO2 10.6 micron. Efficiency 1% maximum and 10 to 15% maximum. Then spot size 0.015 mm, 0.075 mm. That means it is ability to cut that minimum material from the workpiece, this spot size. Then that beam output, the energy is required. So 10 to 100 watt, here 0.1 to 10 kilowatt. Now peak power is a 200 kilowatt, and here 100 kilowatt. Peak power means maximum power is required for these processes. So student, you have to just remember these lasing materials parameters, these process parameters, and near about that range of these values. Then advantages of LBM. Similarly, every process has a common some advantages are there. Then after that respective process, there may be some different advantages. So there is no contact between cutting tool and workpiece. There is a common advantage for the all machining processes. precise machining can be done. That is very important because very high energy of laser, that is high amplitude of energy, so that is a precise machining can be done. No chips formation because it remove in form of melting or vaporization. Possible to drill micro holes. So micro holes can be possible to drill it. Then metallic as well as non-metallic workpiece can be machined. Before this, we have already learned that EDM, WEDM processes. That processes are both are metal, sorry, cutting tool plus workpiece is required as a conductive material. But here we can done the operation on non-metallic also. Then laser beam processes, there is no contact between tool and workpiece, hence there is no issue of tool wear. Then refractory materials can be easily worked. Refractory material means those material have sustained stability in the every temperature condition. Then easy machining of brittle and non-metallic and hard materials. They can also work on the non-metallic materials. And this process is also used for welding of dissimilar metal like electron beam machining process. It is also used for particularly welding processes. So we'll see the next, that is a limitation. So every process has some limitations are there. Let us see one by one. So LBM is applicable only for thin section. That is very important because small quantity of material is removed. That's MRR is very low. Hole drill maybe have slight taper formation. In EDM also same problem, that drill may be taper, but in WEDM you observe there exact straight line hole is possible. So durability and reliability of the system is limited. Means that process has this disadvantage, means their life or that xenon tube, that ruby rod, that materials validity is there. So that's why their system is limited. And due to low production rate, efficiency of the system is low. For that purpose, that operation is precise, so it required more time. Then there is a common disadvantage. Initial cost, operating cost and maintenance cost is more. So high skill operators are required. So there is a common disadvantage for all the processes. Skill work is required. And related to the conventional machining process, that is low MRR, is low material removal rate. And at the last we are going to see that is the applications. So application, in number of application we have see here, that is automobile components, aerospace component, electronic component, medical industry. Use also here removal and cosmetic surgery. In number of applications is used in laser beam machining to produce tiny holes. Tiny holes means as per requirement to tiny holes are make. Then laser cutting. There is a common basic principle. It is used for laser cutting. Then laser drilling also used. Then complex part can be machined precisely, such as making of parts, such as letters, numbers, codes, etc. This is also used in some medical surgeries also there. Okay. So these are the applications. So student, I hope understand this, what is exactly laser beam machining processes. So continuously we will see the next process, that is ultrasonic machining processes. Ultrasonic machining processes itself name indicate that ultrasonic means that is a one of the wave, and machining process, this is a process under the cut the material from the workpiece. So that is ultrasonic machining. So now we'll see principle. Ultrasonic machining, it is shortly says USM, is also called as ultrasonic vibration machining, because without vibration does not form the waves. So that's why ultrasonic vibration machining is the machining process in which material is removed from the surface of the part by low amplitude and high frequency of vibration of tool against the surface of material in the presence of abrasive particles. So ultrasonics are used in the low amplitude and high frequency. So just imagine that frequency range is 2000 to 20,000 to 30,000, and as per the Indian standard that frequency is only 50 hertz, 50 to 60 hertz. So that just imagine that type of frequency is used to for the cutting the material with the help of abrasive material. So abrasive particles is also like aluminum oxide, silicate carbide, boron, diamonds, etc. Now we are going to see that setup of ultrasonic machining. That setup is very simple. Every process, workpiece and cutting tool is the common, but that cutting tool material is different. But we are just showing as a block diagram. Okay. So workpiece is here. So workpiece always connected to the positive terminal as an anode. Then cutting tool is always connected to the negative terminal, that is cathode. Then here you observe abrasive slurry, and there this arrow indicate for the pump symbol, then pass through these hose, that is the nozzle, and high jet of velocity of the slurry get mixed in between cutting tool and workpiece. Because the principle we have already said that ultrasonic waves are used with the help of abrasive slurry. So that's why these different setups are required to supply the abrasive slurries material. So abrasive slurries material like aluminum oxide, silicate carbide, then boron, diamonds materials are used in form of slurry, that is nothing but liquid form normally. Okay, and that pump is required to low pressure to high pressure, then transfer to the nozzle that function is pressure energy is converted into kinetic energy, and then high velocity of kinetic energy, that slurry gets mixed in between cutting tool and workpiece, and then with a low amplitude and high frequency base, that material gets removed from the workpiece. So that's why here that frequency is very high. So that's why need to be one of the cooling system is required. So avoid that some effects like distortion of stresses. So here that cooling water is in and out provision is there. Then ultrasonic oscillator is nothing but a vibrator, so that waves are formed, so that waves are low amplitude and high frequency wave. That frequency is near about 20,000 to 30,000 degrees hertz. Then tool horn is there. So tool horn means that's the shape is provided like funnel. So that horn means there is a provision to pass these ultrasonic vibration waves like nozzle. So that is shortly says tool horn. Don't consider that horn means different to make a noise. Okay. So this is the setup of this ultrasonic wave. And here we are going to see in the 3D, not 3D, that is a colorful, how it works, workpiece to cutting tools. It's very simple principle. Now we are going to see the constructions. Same, you have to put up that parameters, power source. Every process is that power source is required, but here required high frequency ultrasonic wave to produce these high frequency high voltage power supply required. Transducer is a device to control convert electrical signal into mechanical vibration. It also works on the base of the sensor also, but they have to convert electrical signal into mechanical vibration. So in USM, magnetostrictic type transducer is used to generate mechanical vibration, and that transducer is made by material nickel or nickel alloy. Should remember that transducer materials always nickel or nickel alloy. Then booster. Booster is the device used to amplify the mechanical vibration. Amplify the mechanical vibration generated by transducer and then supply it to the horn. Horn already gone through this. That is a provision, nothing but a nozzle. Then tool. The tool is used for the USM must be made of tough, strong and ductile material because it can sustain the low amplitude and high frequency, because indentation by abrasive particle does not lead to brittle fracture of it. So there may be chances to brittle material get fracture. So tool holder or horn, as the name indicates, unit connected to the tool to the transducer. It transfer amplitude vibration from booster to the tool, so it must have high endurance limits. Now similarly working, it works on the same principle of ultrasonic welding. It uses as ultrasonic waves with low amplitude and high frequency of these parts. This machining uses ultrasonic waves to produce high frequency force of low amplitude, and which acts as a driving force means with the help of abrasive slurry. So that already said that ultrasonic wave with a frequency is 20,000 to 30,000 hertz, and its amplitude is very low, that is 25 to 50 microns. Because already said that frequency, imagine as per Indian norm that max standard frequency is 50 to 60 hertz. Now here 20 to 30,000 hertz. The frequency vibration transferred to the abrasive particles contained in abrasive slurry, and that slurries to brittle work and remove the metal from the contact surfaces. So how it works? At the beginning, high frequency current passes through the transducer, and this transducer convert high frequency electrical signal into high frequency mechanical vibration. This mechanical vibration passes through the booster, and this high frequency vibration amplifies booster and send to tool holder. It is also called as horn. That horn transfer this amplitude vibration to tool, and this vibration makes tool to vibrate at ultrasonic frequency. Due to vibration of tool, abrasive particles also vibrate at this high frequency, and these abrasive particles strikes on the workpiece and remove the material from the workpiece. So this is the process. Now we are going to see that process parameters. So retain that process parameter also same. Power supply, then abrasive material, which materials are used, that is aluminum oxide, silicon carbide, boron carbide and diamond. That amplitude of vibration we have already mentioned, that range. Abrasive size is also mentioned. Frequency, feed force is required because related to the tool dimension, that feed force is controlled by the servo mechanism. And then volume concentrated of abrasive in water slurry. Now advantages of this process: machine all sorts of the hard particles, because that frequency is very high, so that's why hard materials can be cut. Generate less heat, because their abrasive slurry is used and then the wave, so that's why heat is generated less as compared to EDM or WDM process. It can be used to drill circular or non-circular holes on very hard material like stone, carbide, ceramics or other brittle materials. That process generally used for brittle materials like non-conductive materials also, glass, ceramics can be machined and can produce high tolerance parts. That tolerance value is high. Its total variation permitted by the design in both direction, positive plus negative. So there are also some limitations for this process. So unnecessary large grain size causes defect. Means in abrasive slurries, that size should be standard because when that size gets vary, so unnecessary large grain size causes defect to the workpiece. And low depth of hole, that is a limitation. You produce hole, but there is a limitation of the depth. Then high tool wear, because that tool get directly in touch with the abrasive slurries, so that's why high tool wear as compared to these all traditional machining processes. And low rate of material removal, so that MRR is also low. Then at the last we are going to see that is the application. So student, every time you have to remember at least two application for the each processes. So first, used to machining irregular shape holes and surface impression. As per the requirement, you produce irregular shape of holes or any geometry of the surface. Then non-conductive hard and brittle material can be machined like tungsten carbide, diamond and glass or ceramics like. These are the difficult to machine in conventional machining processes. These, these are difficult to machine in conventional machining processes because as works on the brittle material is not possible in the conventional machining processes, because in conventional machining processes there is a contact between cutting tool and workpiece. So that's why it is not possible. So I hope students can understand properly by these two processes, that is laser beam machining processes and then ultrasonic machining processes. Thank you.